Science isn't just about answers. It's about the questions that lead us to discovery. Did you know that the scientific method has not only shaped our understanding of the universe, but has also unlocked mysteries we never thought possible? Why do we still rely on a process that's centuries old, and how has it evolved to address today's challenges? More importantly, could mastering this method empower you to solve the unsolvable? In this video, we'll unravel the secrets of the scientific method, exploring its origins, its hidden powers, and the ways it could reshape your understanding of the world. Stick around and see how you can harness its potential to think critically and innovate like never before. Don't forget to like and subscribe. This journey into science could change the way you think forever. The mysterious origins of the scientific method. The scientific method feels like a cornerstone of modern thought, but where did it come from? Its roots stretch back to ancient civilizations. Early forms of experimentation were practiced by Greek philosophers like Aristotle, who emphasized observation and deduction. However, the methodology we recognize today began to take shape during the Islamic Golden Age, with polymaths like Alhazen, Ibn al-Haytham, introducing structured experiments to test hypotheses. Fast forward to the Renaissance, when figures like Galileo and Francis Bacon formalized the method. Bacon, in particular, championed empirical observation over speculation, laying the foundation for experimental science. These pioneers understood something profound. Knowledge isn't static. It's built step by step through observation, questioning, and testing. What's fascinating is how this age-old process remains central to today's scientific breakthroughs. From decoding the human genome to exploring distant galaxies, the scientific method bridges centuries, proving its timeless relevance. Could it be that this method's true power lies not in its steps, but in the mindset it cultivates? Consider how modern advancements like CRISPR gene editing trace their origins to centuries-old principles of systematic inquiry. The tools may have evolved, but the process of forming hypotheses, testing them, and refining our understanding remains unchanged. This connection between the past and the future highlights the universality of the scientific method. Why the scientific method rewires your thinking. At its core, the scientific method is a framework for curiosity. It doesn't just lead to discoveries. It changes the way we think. Psychologists suggest that applying this method fosters cognitive flexibility, the ability to adapt, think critically, and solve problems creatively. Let's break it down. The process begins with observation, encouraging you to question the world around you. Then comes hypothesis formation, which requires imaginative thinking to propose explanations. Testing those hypotheses, however, demands rigorous logic and precision. Finally, analysis and conclusion merge creativity with analytical reasoning. Here's the intriguing part. Studies show that engaging in this kind of structured inquiry strengthens the brain's problem-solving circuits. For instance, students trained to use the scientific method in problem-solving tasks exhibited higher levels of persistence and adaptability. The act of repeatedly questioning and refining trains your brain to thrive on uncertainty, turning ambiguity into opportunity. Could it be that mastering this method isn't just about understanding science, but about unlocking the full potential of human cognition? This framework has applications far beyond traditional science. For instance, entrepreneurs use the same principles to test business ideas, analyzing what works and refining their strategies. Writers and artists often employ an iterative process to improve their work, mirroring the cyclical nature of experimentation and analysis. Even personal decisions, like planning a vacation or choosing a career path, can benefit from this approach. The hidden layers of experimentation. The beauty of the scientific method lies in its universal applicability. While we often associate it with laboratories, its principles apply to everyday life. For instance, think about how you troubleshoot a problem with your phone or test different workout routines to see what works best. Whether you realize it or not, you're using the scientific method. What makes experimentation so powerful is its iterative nature. Each test is a step forward, even when it ends in failure. Consider the story of Thomas Edison, who famously tested thousands of materials before finding the perfect filament for the light bulb. When asked about his failures, Edison reframed them as discoveries of ways that didn't work, a mindset rooted in the scientific method. But here's a twist. What happens when experiments challenge our assumptions? History is filled with examples where unexpected results led to paradigm shifts. The discovery of penicillin, for instance, came from a failed experiment where mold contaminated a petri dish. This serendipity underscores an important lesson. In science, as in life, failures often hold the key to breakthroughs. Another fascinating layer of experimentation lies in the realm of citizen science. Everyday individuals contribute to large-scale research projects, collecting data and testing hypotheses alongside professional scientists. This democratization of science not only accelerates discovery, but also reinforces the universal nature of the scientific method. The mysteries of the scientific method in modern science. In today's world, the scientific method faces new frontiers. One fascinating example is its role in artificial intelligence. AI algorithms mimic aspects of the method by analyzing data, forming predictive models, and refining those models based on new information. But this raises a question: can machines truly emulate the creativity and intuition that drive human discovery? Another mystery lies in its application to complex systems like climate change. Scientists use the method to build models and test interventions, but the scale and interconnectedness of these challenges make experimentation difficult. How do we apply a centuries-old process to problems that transcend traditional boundaries? Finally, there's the ethical dimension. Advances in fields like genetics and biotechnology push the limits of what the scientific method can achieve, but they also force us to confront tough questions. Just because we can do something, does it mean we should? The method provides tools for discovery, but it's up to humanity to use them wisely. Consider how the method is shaping quantum computing, a field that defies classical logic. Scientists working in this domain rely on iterative experimentation to uncover phenomena that challenge our fundamental understanding of reality. The paradoxes and uncertainties of quantum mechanics are a testament to the power and adaptability of the scientific method. The scientific method isn't just a process, it's a philosophy, a way of thinking that encourages curiosity, resilience, and progress. From its ancient origins to its modern applications, this method has shaped our understanding of the world and our place within it. But perhaps its greatest power lies in its ability to teach us how to learn, adapt, and grow. So, what will you discover with the scientific method? Whether you're solving a personal challenge or tackling a global issue, the principles we've explored today can guide you toward deeper insights and greater possibilities. Don't forget to like, subscribe, and share your thoughts in the comments. Together, let's keep questioning, exploring, and uncovering the mysteries of the universe.